Variables are containers created in random access memory by code that stores a unit of information or data. A variable can contain one item at any given time, but that data can be changed over time or varied, thus the name variables. Since the storage is assigned randomly in this random access memory, it's very hard for us as programmers to be able to access it by the address of that memory. We can't hard code that into our code. So instead, we use a name or identifier that tracks to that random assigned space in memory. It's sort of like using a domain name server. If you remember from your CS 105 class, websites all consist of an IP address of 4 numbers, but it'd be very difficult for us to remember those 4 numbers or to work with those 4 numbers. It's much easier to work with a phrase or a URL such as www.southmountaincc.edu when we want to go to the South Mountain website. That's much easier than typing in 140.198.112.175. Well, the same thing happens with our variables. When we store a variable, it's assigned a memory address, so such as 8C5D:33E7. It's hard to work with that. Instead, we give it a name. We assign it a name maybe such as student name. Now, some rules for naming. One of the rules is your identifier name must start with a letter. It can start with an underscore or an @ symbol, though that is not recommended. It may contain numbers. It cannot start with a number, but it can contain numbers. It cannot have any spaces or special characters other than underscores. And you cannot use a keyword. A keyword are those things that show up in blue when you are typing your code into Visual Studio. The best practice is to use camel casing. So your variables all start with a lowercase letter. Everything is in lowercase except for the first letter of subsequent words. Thus the name camel casing. You get this little hump for each of the uppercase letters. So some valid names would be things like pay rate, net wages earned, area, perimeter, or dog_breed. Invalid names, second name, starts with a number, can't do that. Last word has a hyphen in it, not allowed. String would be a keyword, and then token @ space contains the @ symbol as a special character within the name, though you could start a name with the @ symbol, it cannot be inside of a name. Some others that are legal but really kind of ill-advised would be to capitalize your identifier name, such as last word. You can change the casing in C#, so string all uppercase with lowercase s is actually a valid name. It's just not recommended, and it would be confusing for you reading your code. Avoid that. Again, you can start with the @ symbol. That's okay. It's just ill-advised. It can cause some problems with some cross-platform things. My favorite site, valid name, but it's better if you capitalize the F and the S and maintain camel casing. And then again, you can start with an underscore, such as underscore square with, but it's kind of ill-advised. So let me give you an analogy. So my dog, Serenity Grace, likes stuffed toys, and we try to cycle out her stuffed toys. So she's not always playing with the same toys and keeps her interest. So I'm going to take one of her stuffed toys, this colored Jack, and store it in a closet for a month or so. And to keep it clean and dust-free, I'm going to put it in a box. So we can think of the closet as our random access memory. The location that I'm going to put this piece of data, which is her stuffed toy, will go into a box, a container. That container has a size. And so one of the concerns when we're storing data is how big does the container need to be to store that data. So as I look around the house, I have 3 sizes of boxes. I have a shirt box, so I've labeled A here. I have a box, we'll say a toaster came in this, labeled B. And then I have a refrigerator box. Which box would be the best to put her stuffed toy in to store it? Of course the answer is B. The shirt box is not going to fit in it. It's too small. And the refrigerator box is way too big. It would take up all the storage space in the closet. B is the appropriate answer, and it fits perfectly in B. and I give it a name or label the box dog toy. So we create variables in code by listing the data type and its name. The data type dictates how big a box, how big a container that variable is being stored in. So some of the variables that we'll work with a lot are strings, ints, which stands for integer, and double, which is a numeric data type that can have a decimal. Integers are whole numbers, no decimal. And so in declaring those variables, setting aside that piece of memory, these statements, string, dog name, semicolon, would create in memory a space to contain a string value that we're assigning the name dog name. The next line, we're creating a variable of an integer data type, type int, and we're naming that dog age in months. That's going to be a whole number. And then the variable named dog weight is a double value. It stores a decimal. So once we create a variable, we can then assign a value to the variable, put something in the box. So I can assign the literal string Serenity Grace to dog name. I can put 46 as her age in months in the variable named dog age in months. And I can assign a value of 95.3 as her dog weight in pounds. We can assign a value when we create the variable as well. So I can create a variable such as string dog name equals and assign it the value Serenity Grace. A variable should only be declared once within a given scope. So I wouldn't want to redeclare that variable. Instead, I would simply use the variable without the word string. But we always have to declare a variable first before you use it. Now, I mentioned it has to be declared only once within a given scope. And the scope would be, you can have a local scope within a particular handler or event procedure or method. So variables declared in that event procedure or method have a lifespan of just while that little piece of code is running. We'll see a little bit later we have class level variables. And that is scope where the variable can be accessed throughout our entire program within all the different methods or event handlers that we would create. So when we think about data types, there are quite a few. The ones highlighted in yellow here are the ones we'll use primarily in this class. String, int, float, double, and bool. There's more than that are in this chart. Notice that for integer, these are whole numbers. There's different types based on how big that integer value is. So int is the most common, but if it's going to be a small number, maybe somebody's life in years, might use a byte for that, save a little bit of storage. Or there's short, which has a plus or minus range of 32,767. An integer has a plus or minus range of a little over 2 billion. And then there's others, such as a long, which has a very large plus or minus range that that number can exist in. Floating point values are those that have a decimal value. So we have float, double, and decimal. Boolean contains a true or false. And then we have a date time object. As I said, there are others though. There's an unsigned integer, which rather than going from plus minus 2 billion, just goes from 0 to a little over 4 billion. So basically, we gain half of that space back by not being able to handle the negative numbers. There's an unsigned short. There's an unsigned long, that the maximum value is twice that of what a long value is. So you can decide which is going to be the most appropriate data type to store your data in a variable based on what you anticipate the range is, or what that value should be. You don't want to use something too big because it's going to take up more memory. You certainly don't want to use anything too small because then you're going to have errors where it runs out of the storage space. In terms of these being different size containers, here's a listing of the different amounts of memory that are required to store these objects. So you can see that a double takes 64 bits, but a float only takes 32. The difference being that a double can store twice as many significant digits as a floating value, but it's a bigger box. Most math expressions return a double value. So double is what we primarily use for working with numbers. Unless we want a whole number, then we use integers, at least in terms of this class and the types of things we'll do. If you were doing a lot of scientific things, more in the computer science area, maybe you wanted to keep track of how many feet it is to the moon, then a long value would probably be more appropriate than an int. Every language has variables, just how they're declared is slightly different. And so again, we want to declare our variables with the data type, followed by the name, using standard naming rules, and a semicolon.